Right, brilliant. Thanks for coming. I'm really relieved to see so many people here. I was a bit worried yesterday that nobody was really going to care about heating design on one of the hottest days of the year. So probably. Wait. You said it wasn't very good on the t-shirt. So yeah, probably good that it wasn't doing this yesterday. You would have been even less interested. So why are we all here? Well, because we all want to save the world, right? So we want to create a better future. A PowerPoint presentation that randomly stops working. For some reason, it's not going on to the next slide. So yeah, we want to make a better world. We want to make a greener world. We want to reduce our impact on the environment, and we want to live in healthier, happier places. So. That's always kind of the vision that we have in our minds and the future of where we're going. And so we kind of, how do we eat an elephant? Was anyone in that presentation yesterday? In small pieces. So like my small piece, the first step before I get on to, publicly disgracing Trump and whatever else is in the plan, I'm just going to start with getting better informed design of building services and how so we can reduce the energy consumption of buildings. Who knew? Who knew this was going to happen? Okay, I can do it like this. I can push the buttons. There we go. There's the future world. This is not my image. A Google image that just kind of relates to vaguely the way I see it. This is where I'm going to live in the future, right? So. My little bit of it is this. How are we going to get there? We want instant feedback on our design decisions, right? So as soon as we make any changes in the architectural model, we want to be able to see what impact that's going to be having, rather than having to take a model, go away for a couple of weeks, run a different analysis, look at the way it's going to impact on the boiler sizing, da-da-da-da. So, and also we want to make it more interesting, right? So, was that you? Thank you. So we want to spend less time doing boring, repetitive tasks and more time doing actual design. So that's me. I'm a mechanical engineer. I'm a designer. And that's what I want to do. And every time I come to Revit, that's what I'm trying to do. I'm trying to make it a better design tool. So I'm really interested in the data behind it and how we can add calculations into the model. And much more than just using Revit as a drawing tool or a 3D coordination tool. In fact, I don't really cover much of that in this class, and I don't apologize for that really, because I don't think it's as interesting as data. So this is what I'm going to do in the next 52 minutes. I'm going to go through a heating design process all the way from the beginning, from the inception, right to the very end to a detailed design. I'm going to swap between presentation and live demos, so I'm actually going to probably spend more time, hopefully, in the Revit model doing live demos, which means two things. One, I'd like you to kind of ask me questions as I go, and if there's things like, oh, what if we do it like that, that would be great. A bit of interaction is really helpful. Also, because whenever I do this sort of thing, someone from the audience usually tells me something that I didn't know before, so I appreciate things like that. It's really good. And the other thing is, inevitably in live demos, we're going to have a few moments where we get that blue circle of patience, and so it would be good to fill that void with some chat, some banter. So these are the key learning objectives. This is what we're going to learn how to do, carry out mechanical calculations in Revit. That's kind of the key thing. I'm going to use, as I had here, mostly core Revit functionality, a little bit of Dynamo, and a couple of add-ins that we've actually made ourselves in Hall-E. I work for Hall-E, by the way. That's cool. So here we go. Heating design workflow. So I start with the beginning. We're going to put some spaces into the model, see how we can create treatment plans. So early stage, kind of stage 3 in new REBA stages in the UK. This is pretty much the bulk of what we need to do at that stage. I'm going to look at how we can use Revit for space heating loads. Then how we can take those heating loads, push them into the terminals, add them up through the pipes, and we can look at sizing the physical pipes, sizing the system, getting the duties back at the boiler, and having things all connected. So that's the kind of high-level thing. In each of those 4 areas, I'm breaking it down into 5 chunks. So there are 5 kind of steps in each area. And that's what these are. So this is a whole 20-step process that I'm going to do in 48 minutes. The ones, as the key says, the ones that have got a bold red box around are things that we've made an add-in for. Generally, it's stuff that you can get third-party add-ins, or maybe you've got your own as well that do these sorts of things. The ones with the dashed line have done a little Dynamo script. Everything else is just core Revit functionality. So if you're terrified of Dynamo and you don't have anyone with programming skills, then you can still do a lot of other things that I'm going to show you in the presentation, just with core Revit functionality. And after we've done all that, this is what we're going to get. So these will be the outputs. We'll have a model. It'll be sized. We can get some drawings out of it. We can get room data sheets. These nice color-coded treatment plans. And some cool stuff, schedules and things that maybe you know about. Part 1, spaces. So a little bit of preparation before I put the spaces in, which is this. Open a new model, link in the architectural model, acquire the coordinates, set room bounding, and align levels. So I've kind of done that as a preparation because I figured that you might find that not so exciting as part of the demonstration. So that part is done. I'm going to pull in spaces and names using Dynamo. We've got a tool that we've created that links Excel with Revit. So we can pull space data in from Excel into our Revit model. We can create some nice color-coded treatment plans. Again, depending on how I feel, we'll use either our own Sheets and View Manager to create those, or maybe just make them in Revit. And then we can export individual room data sheets back out. So. Incidentally, the presentation has a video of what I'm about to do, but I'm going to do it live because I like a challenge. Here we go. So I've got a really simple building, a relatively simple building, 3-story office block, a bit of plant space on the roof. I'm not going to do the whole thing. I'm just going to kind of pick areas to work on, but this is the model that we're going to be playing with. So I've got some spaces views set up. Oh yeah, incidentally, I might go through things quite quickly. What I'm aiming to do is just show you what's possible in Revit. And I've now got 47 minutes to go through all this, so I might go relatively quickly. We'll have opportunities to ask questions, but I might just presume that you kind of know what some features are. but do stop me if you get really stuck. And if you want to ask a question, there'll be a microphone that can come around. So yeah, if you do have a question, just put your hand up and we can get a microphone around. Right. So here's a blank view. No spaces in there at the moment. Obviously, the normal way of doing things, analyze space, set your upper limit, place spaces automatically. You do this on each floor. You might have issues where, for example, this has an atrium level. So in section, this kind of looks like this, whereby that space kind of goes up here. And that's something that you'd have to know about and how those spaces work together in order to put them in here, set the upper limit to the roof, put different spaces in here, etc., etc. So it's a bit fiddly. What we do with Dynamo, and I'm using Dynamo Player, by the way. I'm happy to go through the scripts later if anybody's interested. I don't even mind sharing the scripts if you'd like them. But yeah, using Dynamo Player just to show how quick and easy it is. So what this is doing is it's taking the rooms from the architectural model. So I hope you understand what I've done here. I've linked the architectural model in. And there are rooms in the architectural model. And what the Dynamo script is now doing is going through that linked model, finding every time there's a room. And then in our MEP model, it's placing a space, and it's copying over the properties from the room into the space. So it takes the name, it takes the number, and it takes the total height of the room as well. This took about a minute when I tried it earlier, so it'll probably take 10 minutes now. Yeah, okay, so there's a question just down here. I'm just going to get a microphone, because they're recording the question, so we have to be able to hear it. Yeah, thank you. Thank you, Claire.
So when you run the Dynamo script, the spaces that it puts in there, does it tie them to the upper level the same way as you would if you were placing it manually?
Actually, what it does is it takes the offset from the room. So if your room is at level 0 and the upper level is, or the upper limit is level 2 plus 2 meters, it won't do that. It will say that the upper limit is like the absolute value. So it might be like 23 meters or something. So it just works out the difference in height between level 2 and level 0 and then adds the two numbers together.
Okay, sorry, does that, excuse me, does that come up with any kind of errors when you look in the heating and cooling loads analysis?
Okay, we're going to have a look at the heating and cooling loads in a bit.
Okay.
And that's a whole different kettle of fish.
Yeah.
It can come up with errors. And of course, if the architectural model isn't set up in the way that we'd want it to, amazing. So it might just come up with errors now because, you know, it's a live demo and everything. So this is what I'm going to do instead. I'll go into Dynamo proper and just see why there's an error, unless somebody's updated a package since lunchtime I wasn't aware of. I am prepared. I've got backup models, by the way. If this all goes wrong, I can skip ahead. So once here we go. I mean, this might be quite good actually to see the Dynamo script, because then you can have a look at what's going on in here as well. Incidentally, I'm not particularly brilliant with Dynamo. I can just about get my head around scripts that people have made for me, but I'm more of a commissioner. So yeah, if you're kind of sat there thinking, I really don't want to have to get into visual scripting, you don't have to, but you just need to know someone who does. And to be honest, it doesn't seem too daunting once you learn a few things about it. So I'm going to run this here, and then hopefully it will actually tell me what my errors are. So, pros and cons of Dynamo Player. 1, it's really, really easy when it works. 2, when it doesn't work, you've got no idea what's going on. It's like an iPhone. So what this script is doing is taking, I'll use a cursor actually, it's looking for the linked model. It's pulling the rooms out of the linked model. It's taking the information from the rooms. That's what this is. And it's pushing it into spaces. So this pink box down here is actually creating spaces, and this one here is pulling the data from the rooms. That's all these cables are all about, and pushing it into the spaces, so name, number, and offset. The green box up there is doing that thing with the offset of taking the distance between the levels. How many people are familiar with Dynamo? Yeah. Cool. How many people have made a script that does this? Loads. Maybe yours works better than mine. Okay, so this time it just worked. So maybe the answer is Dynamo Player's got some random bugs, and then this works. So you can see in the background that it's created the spaces. I'll just minimize that for now. Well, that's a bit of a relief. And if we look in plan view, I'll just switch on the sections. Oh, what am I doing? Spaces. Thank you. I knew it would do that. Yeah, so I've made an error because I forgot I have one of these random levels in there. My mistake. So you have to have the levels set up properly as well in order to do this. I'm not going to go back and change that now. It kind of gets the message across. But yeah, you can see what it's done. It's taken the same height from the room and taken the offset out there. Okay, so now I've got spaces in my model, and if I go into a view, so I've jumped the gun. This is really good. So we've got an add-in. This is what I was going to say. This is already populated with data, so it's only pulled, all it's done is pulled in the room, the space name and number, and a number of people. But look at all this data that's in here, okay? The reason this has happened is because, so we have an add-in that links between an Excel sheet and Revit. So it's this Excel sheet, we have space types, and they're Uniclass 2015 standards, descriptions and codes. And then we have a bunch of default parameters. So this is something that we are currently developing as like an in-house company standard. So each of these room types is then assigned here. So Uniclass 2015 description is assigned to the individual spaces. And that in turn just pulls the data from Excel and populates these. I wasn't expecting that to happen, but when I'd practiced with this model before, I'd set up the data link already to do this. So it did it automatically, which is even better than what I was going to demonstrate, actually. But I'll show you the tool. So what this does, no, I'll just repeat myself if I say that again. I'll wait for it to open. Not responding. Okay. So all this is doing is saying, where's your Excel file? That's what this is. What's the name of the table in the Excel file? So we've got lots of different tables, and it's that one. What header are you looking for? And what parameter are you taking? So I originally had this set up to look for this Uniclass 2015 description. And then when I type in the description, it pulls the data through into the other parameters. But that became kind of boring because as an engineer, I didn't really want to be going through all of these spaces, typing in Uniclass description over and over again. It's not a very interesting job to do. So I had the thought, is it already in the architect's model, right? So this is a level 2 BIM project. So obviously the architects, how many architects are in the room? None. Come on, surely some architects. Hooray, this is great. I can say what I like. So obviously the architects have added Uniclass codes, the classification codes, in accordance with the level 2 BIM procedures. And of course they have, because I'm the architect on this project, so I went in and put them in. So yeah, Uniclass 2015 codes are added, and I thought, if that's already in there, why don't we just relate those codes in the rooms to my Excel table here, and just pull the data directly through, which is exactly what happens. So on the one hand, I apologize that I didn't show that in a granular way, but on the other hand, isn't it cool that I didn't even have to do anything and all the data was already there just based on what I had in Excel? Incidentally, so the reason we do this is also, again, because if engineers are not necessarily that au fait with Revit, but they want to have an input, they can do it all in Excel. So there we go. So now we've quickly got a bunch of data in here, and then we can make a load of treatment plans, right? So a couple of ways we can do this. Yeah, I'm gonna try this. So you can just make some new layouts, apply view templates. I'm going to just demo a tool that we have ourselves. So if I want to make, so I've got zones, north zone and south zone, which relates to scope boxes. And then for each level, 0, 1, and 2. So this is just going to set up views and sheets. I might just make views, it's slightly quicker. And then I've got a bunch of view templates in here. So that's what this is. So I want heating strategy, lighting type, lux level, ventilation strategy. Create a bunch of drawings. I won't make title blocks. I'm just going to create the views. And that will go through and create the views. So, so again, this is our own tool that we've developed, but there are others on the market that do similar sorts of things. And all it's doing, in case it's not obvious, is for each level, for each scope box, and for each view template, it's creating a view. So we're going to end up with 2, 6, times 4, 24 views. Okay. In here, there we go. So my heating strategy views, and I've got for level 0, that's like the master one, and then my dependent views, north and south. And you can see that it's applied the color scheme already. I'll need to drop a legend on the side, but there we go. Now I know what the heating strategy is. So super, super quick and easy way of delivering that information. And again, for a stage 3 design, this is pretty good. This tells you what you need to know. Once you've got all that data in there, and you've got data for all your individual spaces, so for each of these rows, we can create a sheet. And again, this is we'll use our own in-house tool. But again, there are quite a few alternatives that do this. So we've got some standards for room data sheets, and I'll just save it on the desktop. Okay, and that's just going to export all of that data into an Excel format. So again, if you want to, here we go. So if you want to be working outside of Revit, then you can do that. So for each of these tabs is one individual space. So there are like hundreds of spaces all the way along here, and they have all their data for each individual space. I suppose you could do that in Excel anyway, but then you would miss out on having the nice color-coded plans. Cool. So that's all we need to do about spaces. The next thing that can go wrong is heating loads. So once we've got these spaces, this is part of the vision. This is where we're going to be going. This is how we're going to be doing heating and cooling loads within Revit. So at the moment, the process is very much about exporting spaces to IES. How many people do this? Export spaces to IES, yeah. And how does it go? Great, terrible, terrible, bad, yeah. Really quite problematic. So, I mean, there are ways around this. You can tidy things up. There are certain benefits to doing that. You can run your analysis in IES, bring the data back in through Excel into Revit. So that is one option. But a neater and tidier way that works is to do this in Revit. So so I'm using Revit 2018, by the way. So this energy optimization stuff is there anyway. I've added in, there's an add-in, free add-in called Insight 360, which provides you with a few additional bits of calculation functionality. So I've got that add-in as well. Might have worked. So what this does is it uses Energy Plus, and it's a heat balance method, which is very comparable to the admittance method that we're using here. Okay, it's being generated. That's okay. So what's happened is I've uploaded the model to the cloud, and it's computing it on the cloud. So I might go away and do a few other things, and then when I'll get an email, although I'm not supposed to have my phone on. So I'll get an email to confirm when it's ready. It'll probably take about 5 minutes to give me my results back, and then I can pull the results back into the spaces. So while it's doing that, it's doing it in the cloud, so I can get on and do other things in my design. I think what I'll do is, yeah, all these little blue dots, by the way, that's come from the Dynamo thing for generating spaces. I can hide them, but you know, I'm not going to. So what I'm going to do is I'm just going to draw in a basic pipe system. So again, early stage, all I want to do is put some risers, and I'm going to use pipe caps. So we've made mechanical equipment family for pipe caps, and actually I'm going to put them at 2800. And what this allows us to do is specify a flow rate, a pressure drop, just notionally for the whole floor, for example, in this case. And I'm going to make it a 50 mil thing. So this is just a little disk you can see from the type selector on the top left. And I'll put one in here. It's going to think it's a radiator. We can fix that. That's a flow connection, and here's a return one. And I'll do the same thing with this. that sounds good. All right. Here's a return. Oh. So these are just placeholders that we can use to draw our systems from. So that's a return. It's a return as well. No, you can tell me, if I get it wrong. If you see that I've done something wrong, you can say. And I'm just going to draw my system straight out from here. So that's up in the corridor, up in the ceiling void. I'm going to go into a riser, and then I'm going to go up to like 30 meters. I'm actually not sure how tall the building is, and draw another horizontal. So I've drawn a riser there, and if I cut a section, we can see what's happening. So I kind of only need that to go down to my rooftop plant room. Let's find a quicker way. So I quite often do this, just use the arrow keys to nudge stuff around. Probably not amazing practice. And then if you do shift and the arrow keys, it does a big jump if you didn't know that. And I'll do the same for return. Actually, what I might do is use parallel pipes just to demonstrate that. So, wrong one. So parallel pipes, I want 250 between them. And if you haven't used this before, we hover over and it's the offset, and if I push tab, it's going to do the whole run. So I've now got both systems, and that's an LTHW flow. Make it a return, align this to this, and connect to that. Is it actually connected? I knew that. Right, so we've got some flow information in the pipes. So when we select those pipes, 2 litres a second is going in there. So this is, the reason I'm doing this is so that I can get a bit of flow data going back up to my boiler without having to model the whole system, okay? Probably a shortcut way of doing this, if I just copy and paste. So I use the clipboard, paste to align to selected levels, then I just paste it on the other 2 levels. And when I go up to, I could do it in here, I suppose. I'll do one at a time. And then just drag them in and join them up. And do the same for the flow side. Okay. So now that I've got this, one thing I can do is tag all my pipes with a schematic tag. So we have these tags that we made that just pulls out the size, the flow rate, the velocity, and the pressure drop. If I make it maybe medium detail, it'll be single line. So it looks a bit more like a schematic. The wall is bothering me, so I'm just going to do this. And maybe it's quicker, maybe not, but maybe I'm just going to do this. Tag all pipe tags, that's my pipe schematic. Switch on the leader, OK, and then we've got a bunch of tags floating in midair. Cool, don't need this one anyway. OK, so quick checks, and we can see now what our flow rate is. Oh, and the pressure drop's ridiculous. So even at this stage, I can just select the whole pipe run, use the duct and pipe sizing tool. So this is sizing things based on, I've put these values in already, just that I want a maximum friction of 220 pascals and a velocity of 1. You can change that to whatever you like, and it should be relatively quick. So that will just update. It's changed the size, now it's a 100 mil pipe and more sensible pressure drop values. That is based on, if you go to manage, MEP settings, mechanical settings, you see under, well, both under duct and pipe, but as we're looking at pipes, there's this calculation feature. And you can choose which calculation method you want to use. In the UK, SIBSE recommends the Harland equation, and that's written out there. So you can see, it's not a black box. You can see what equation it's doing. That's the pressure drop that it's calculating. So when you click on a pipe, Here we go. That's the pressure drop that we're getting. So pretty good, pretty gravy. I'll go up to. I'll stick a boiler in my plant room. And yeah, again, oh yeah, so the references things bothers me as well. So we made this add-in, remark selections, and we can do, this will just automatically remark based on a predefined schema. So it will be type mark, the level it's on, and then it just numbers them numerically. So there we go. If you didn't want to see like radiator reference on a boiler. So a number of ways that we can do this. And this time I'm just going to do this connect into. So you select a piece of equipment, you click connect into, you choose which connector you want to go from, in this case the LTHW flow, and in this case LTHW return, and then select the return pipe, and it will connect them up. So we've now picked up a flow rate in the boiler, LTHW flow rate 6 litres a second. We've got an LTHW flow and return temperature, which in turn gives us a heating duty. I've made a tag just to show us what that heating duty is. So we can see that that heating duty is just calculated based on the flow rate that's passed up from other floors, and anything that we change, let me get rid of a few of these views, anything that we change on the other levels, should have done it in a different way. We'll update that number. So that 504 kilowatts, if I decide suddenly that on the ground floor, oh yeah, here's another tip. I keep accidentally selecting my spaces. I just pin them, so like select the whole floor plate, filter it down to spaces, and pin them. Drawing pin. And then I've got the little feature on down here, don't select anything that's got the drawing pin. It just saves loads of hassle. Okay, so if I change the flow rate down here, instead of 2 litres a second, I have 1.5, then it's going to update the duty on the boiler, okay? Hooray! So things are getting connected and stuff's updating and changing. Exciting. Let's get into a little bit more detail then. By the way, I've ditched doing my presentation, but I'm going through the same process that I've written out in the presentation. So when you come back and look at it, you'll be like, oh yeah, I remember all this stuff. Okay. So this time what I'm going to do, I'm going to start putting a bit more detail. So I'm going to put some radiators around in these spaces, and I'm going to connect them back to some pipes in the corridor. So just delete those for now. Arbitrarily pull this into random space. Incidentally, actually, that's probably why I should have done the presentation properly. Something I very highly recommend we do before you get to this stage is this. As I said, I wasn't really going to talk about coordination, but it's a massive problem that we keep coming up against. And doing a corridor section at the very start of the project and writing out what your offset heights are going to be is like a massive, massive headache saver for later. So if you learn nothing else, do that so that you know, and everybody knows on the project, oh, if I'm drawing a pipe down the corridor, it needs to be at 3 meters. And my takeoffs are at 2800, and my ducts are at this, you know, whatever. It just saves an awful lot of hassle. So I'm going to draw a pipe down the corridor at 3 meters. I'm going to put a cap on the end. In fact, I may as well I'll do this offset thing. So slightly different to the parallel pipes feature, just offsets. And now what's happened is, you might not be able to tell, but I've connected an LTHW return system to an LTHW flow system. If I hover over that and tab until it selects the system, but not the pipes, and then hit delete, it will remove the LTHW return system, and it will just assume the system from the other thing. You know what I mean? What's a good way to do this? So I kind of have like different ways of doing things every time I do it. So I don't think that's worked. One of them worked, one of them didn't. So I just copied a couple of pipes across, and then what? It's done something amazing. Maybe I should do it like this. I mean, I guess you guys are pretty familiar with this sort of thing where Revit, there's like 100 ways to do the same thing, and sometimes you just have to do it a different way. And I quite often do this, detail lines for like trimming stuff. Don't know if that helps you at all. So I'm going to select these pipes. At the moment they've got open ends. Oh yeah, I need to pin my spaces on this level as well. So they've got open ends, so I can just do cap open ends. Hooray! 4 caps were added. That's kind of what I expected. And then I'm going to put in some radiators. So I've got single panel radiators. I've set up the family. We're going to edit the family in a moment, but I've set it up so that it offsets 50 mil from the insertion point. I'll come back and fix the tags in a minute. Actually, do you know what? I'm just not going to have the tags on there, and I'm going to put them back on because I'm just so OCD about seeing the wrong label on a thing. Go away. So we're going to add a bunch of radiators. So hopefully you're kind of second guessing where I'm going with this, that multiple, it's always the little things, right? When you're copying, there's that little multiple tick box that's like, again, massive time saver. Hooray. So yeah, hopefully you're second guessing where I'm going with this. So I'm going to put a bunch of radiators in. At the moment, they've got a default heating value of whatever, that'll do, of a kilowatt in each one. But we're going to take the values that we get back from our heating analysis, which is probably finished now, but I can't see my email, so I don't know. And we're going to push that into the radiator using Dynamo, and everything's going to change. I did all the tagging thing anyway, whatever. Did it? It's weird. It doesn't matter, it doesn't matter. So here's a cool new feature in Revit 2018. Once we've put in I put a double panel one in there, and you see how it's a different length. I'm going to come back and have a look at the equations I've got in the family in a minute, but yeah, it resizes as well. So here's a cool new feature in Revit 2018, is analytical pipe connectors. So previously, this would be my advice for connecting up radiators is, and this is pretty good advice, actually. So I'm going to route along under the radiators, come up in the corner of the room, and then connect into the corridor. So I start at the end. See how the offset is 150 mil? That's the bottom of my radiator, but it needs to go down first and then along. So hit spacebar, and it changes the offset to whatever it needs to be in order to go underneath, to go down and along. So yeah, spacebar. It's all these little things make a really, really big difference. I'm going to go up into the ceiling and then connect back up into the corridor. Now with these two, rather than like going in section and drawing little pipes down, I just use connect into. So this works pretty well with pipes, not so well with ducts, just probably because they're big. So there we go. So I've connected, and you can tell because they've gone orange, I've connected those radiators into that pipe, and I'm going to do the same with my return. I forgot to follow my own advice already. You can tell me if I do it wrong. Undo, create pipe. Okay. So click on the symbol, hit spacebar, and then go to the corner. So if you don't hit spacebar, what happens these days in Revit is it will draw the pipe at that offset, but it will go down and then go up at an angle. So then you'll have like a pipe at an angle. So this will be at that 150 offset that you want, but under the radiator it will be down. No, no, no. And now when we do connect into, it's not asking me which connector, because there's only one connector that isn't connected to anything. So there we go, it connects in. And I think there's some better functionality going on in Revit now, because it seems to pick up, if you've got a hydronic return and you're connecting to a hydronic return, it seems to pick that up, which might be something to do with what I'm about to show you. Anyway, so that would be my advice previously for connecting up radiators, so that you can have your flow rates and your duties connecting through your system. But this is a little bit time-consuming and not necessarily that great. Also, nobody asked this question, but surely you're all thinking, oh, you're just throwing loads of clashes in there, right? Look at all these clashes, horrible. And we might get pulled up on that. I personally don't care about these sort of clashes, and I will just try and manage people's expectations that this is okay, this is what I call an acceptable clash, but whatever, it's a matter of opinion. So to get away from these issues, analytical pipe connectors. So we can select a bunch of radiators here. We can click Analytical Connections. So this is a new feature in 2018. And then I click on the flow pipe, and it connects all the flow connectors, and the return pipe, and it connects all the return connectors. And this hasn't physically drawn any pipe. It's just a logical connection between the two, okay? And if I tag the pipe, you'll see it's picked up the flow rate. So pretty quickly, and it goes along, you can see the flow rate is going down as I go along the pipe. So it's kind of doing what we want it to do. Not kind of, it's doing exactly what we want it to do. This is a good feature, yeah? You with me? Thanks. Cheers. And we'll do the same thing over here. So again, analytical pipe connectors, flow and return, and the same thing here. Another reason why I should have left my tags off for now. So we're keeping up. Does everyone understand? Does anyone not understand? Raise your hand. Good. You either understand or don't care. So now we have a fully connected system, just like that, very, very quickly. We've got the major pipe work is in place, and so we can use that for coordination, and the smaller pipe work is not, because we don't need it. All we need to know is that those radiators connect up to the pipe. And that's adding up all the way back. And if I go back to my boiler, the heating duty is changing. So if I, again, just to labour the point, if I change a load in my radiator here, for some reason that becomes, oh look, they're 600. I told you they were 1,000. I lied. If that becomes 12 kilowatts, it's going to update all the way back at the boiler. Great. So things are getting connected. And also, did you notice the radiator then just got enormous? So this is something else we've done. Within the radiator family, we've got a couple of equations. One is calculating the flow rate from the heating load. So it's Q equals MCP delta T. You're all mechanical engineers, so you love this equation. And so yeah, pretty simple. It's just taking the temperature difference and the heat load and calculating the flow rate, which gets pushed up through the pipe. Great. The other thing I've done is add in some equations to size the length of the pipe based on the heat output, the height, and whether it's single or double panel. So I took some information from manufacturers, and I got these watts per meter value from manufacturers' data based on the different heights. So this is what, then I plotted a graph and I copied the equation from Excel into here. And it's one of these somewhere. Overall length is watts per meter, here, this. Strike two. So we've got a couple of equations in here that drive the actual size of the radiator. So what's going to happen in a minute when we push the heat loads into the terminals is the size of the radiator is going to change. And everything else is going to change all at once. Magic. Let's do it. So I'm going to just assume that the... oh, actually, I can find out. So if I click on the heating and cooling button up here from Insight 360, it will give me a report of all my different heating and cooling loads in all different spaces, whatever. One thing it doesn't do, for various reasons, is pull that value back into spaces. So if I look at so I've got a schedule of spaces here. The design heating load is just 0 for everything. So yeah, again, we just made a little tool that just pulls that value from the Insight 360 report. Here we go, back in here. So simple, simple. And now we've got heating loads, okay? And I've put in some checks just to say, am I happy with these heat loads? Some of them, I've put a conditional format, so some of them look a bit high. 95 watts a square meter, it's probably is a bit high. Might be something wrong, might need to look at it. Stairwell, it's probably just because it's got a really small floor area. So those are my heating loads, okay? I'm happy to have a discussion later about how valid these are with Tom, because it's his fault. If you have doubts. It's something that we're working on at the moment, and the short version of the story is that actually the calculation that's going on is very reliable, and yeah, it's the future, get used to it. So we've now got, if I tag all my spaces with that information, tag all. Space data with my heating load. So that's the heating load that it should be. And if I tag all my radiators with the heating output that they have currently, and actually, this is why I didn't want to have the tags on here before. Tags. I'm going to do that again. Mark and heat output. Cool. So all this is about to change. So here's Dynamo again. I'm going to show you a few different things happening all at once. So we'll see radiator duties change. We'll see the size of the radiator change. We'll see these schematic E values updating. I'm just trying to find like an impossibly small view of, just to illustrate all of these points all in one go. That will kind of do the job, I think. And we're going to see the duty in the boiler update. You know, we've got a schematic thing here, which will update as well. The other thing that you might be aware of is color schemes. So I've got a color scheme applied here, and if I put a key on to help you, so yeah, anything that's more than 220 is orange, anything that's more than 250 is red. At the moment it's all good because I just put 50 mil pipe in everywhere. So all these things are going to update by magic using Dynamo. I'm going to risk the Dynamo player again and see if it doesn't go wrong. So design heat load into heating terminals. Please close Dynamo before running. Okie dokie. Okay, so this will take a minute, two. And all this is doing is taking that design heat load value that we've got in the space and putting it into the heating terminals in the space. And if you've got more than one heating terminal, it divides it equally between those heating terminals. Oh, it's done it. That was quick. Did you see everything change? I was talking, so I missed it. Everything updated, right? Look, the sizes, the duties are different. Oh, they've all got the wrong references, but you know, whatever. This is updated, the values in the pipes, and my duty in the boiler has updated, okay? So now that we've got all this connected, what this means is that if we get any changes back from the architectural model, I don't have time to do that, but if we get an architectural model and they've changed properties of walls, different sizes of windows, whatever it is, we can then just go through. Now that it's all set up, all we need to do is run the heating load analysis again, and then run the Dynamo script again, and it will pull the information straight through so we can see instantly. Which is only one step away from just, if we just automate those 2 clicks, then we just bring the new architectural model in, and it would give us the information instantly. And with cloud computing power, I guess that would make things a lot quicker, so we could do that. So I'm pretty much there. There's a couple of other things, well, there's hundreds of other things I could show you. but maybe we've got 5 minutes, so that's a good amount of time for people to ask some questions and or have a play. I hope I haven't lost you along the way, because I know I just got carried away and rattled through the whole thing. But yeah, let's go. Who's got a question? Or I'm going to nominate people. I'm going to start nominating people I know to ask questions. Yeah, go on. Go on. So we'll take this one down here, and then we'll have the bald fella at the back there. Hey.
Hi, yeah, so just interested in like your setup at Hawley. Then is it just you doing it, or is it all the mechanical engineers, or
Okay, yeah. So the question is like at Hawley, am I the only person who's doing this, or is everybody in the whole firm doing it, right? Yeah. So the answer is somewhere in between, and some of these features, like adding up the flow rates and doing the pipe sizing and things, is becoming quite common. So a lot of our teams are doing that because it's a functionality we've had for a couple of years. Obviously the analytical pipe connectors is new, so I'm the only one that I know of who's doing this. And we don't have projects in 2018 yet, actually. So partly a slight drawback. Dynamo scripts are being used here and there, so we've got a handful of teams that are doing it. So kind of each of the individual features are kind of happening organically around the place. So yeah, does that answer your question? Yeah, cool, thanks. Go on then. So Andy, we'll take your question. Yeah.
So we've working at Arup, we've invested a lot of money into building a content library that incorporates a lot of the kind of features and data required to drive these workflows, same way as you have.
Yeah.
Is that, presumably you guys have got your own in-house library that you've invested the same kind of time and effort into?
Yeah.
And how, I suppose one of the things that we're trying to achieve is to get some more consistency internally by developing that library, but it'd be great to get some consistency externally so that we're all kind of utilising the same sort of stuff. So what we would be open to sharing our stuff with you guys. Hopefully you'd be open to sharing something similar to kind of drive some of that consistency.
Yeah, absolutely. So this is something that needs to happen through institutions, right? About data consistency. So the point is absolutely valid that these families that we've made, this is like a Hawley generic boiler, and it has a bunch of parameters in that are from our shared parameter file in our company. And yeah, if I gave that to Arup at ACOM or whatever, then you wouldn't be able to use the same things. You wouldn't be able to use the same Dynamo script because they're looking for like our naming structure. And even some of the add-ins that we have are bespoke to our tool. So yeah, it's quite, at the moment, it's quite proprietary, I suppose. It's quite bespoke to what we do. And the way to get around that, I think, is initiatives that various institutions, unfortunately they're not collaborating with each other, but various institutions are coming up with these standards. So a common data standard, a common naming structure across all of these things that's why it exists. All this level 2 BIM stuff that's just annoying because it's like, oh, I've just got to change all my names of stuff and put classification codes in and all this stuff. That's why it exists. If we can standardize all that boring stuff, then we can do these things much better as a whole industry rather than little specialisms breaking off and doing their own thing. As we've discussed previously, I'm very happy to be working with other businesses to do that, and I think that's what we all have to do as a team. It's a Lego movie. So yeah, I mean, that's a really good point, so thank you for raising that. I hope that's helpful for people. Yeah. So yeah, great, there's a couple of questions here. We've got 1 minute and 9 seconds, go.
It was just a quick one on how you drive your loads. I'm assuming that you rely on a kind of architectural model having the relevant data.
Oh, yeah.
So it's set up with a U values and whatever else is going on.
Yeah, actually I had the architectural model open because I was going to show you that, so nice, thanks. So very, very, very quickly then, here's my architectural model, and in here, so basic wall, whatever, in the structure, for each individual material, so this is about the Revit material database, so let's take this like fiberglass batten, for example. And this is all in Revit as normal. Usually you only see 3 or 4 of these tabs. You have to add in the thermal tab, and it pulls in the information. So there is a library that Autodesk have of all these properties of materials, but you do have to go into your architectural model and make sure that this is set up, because it probably won't be. And this is about collaboration, getting together with the architects and sitting down with them and saying, these are the thermal properties that I want in the materials, and then you'd be happy with, here's the U value there, 0.374. So to be happy with the value that you've got in your constructions, and that is the value that gets used in the heating loads. There are different settings in here. Again, as I say, I sort of glossed over this a little bit, but there are different energy settings that we can do, and you can either use building elements, which is that stuff, or conceptual masses, and which are defined in here. So there are different ways, or in here actually. So there are different ways of doing things. Yeah. Is that all right?
Yeah, no, that's perfect. I suppose it's how are you finding it? Does it work well with the architects you're dealing with, and do they sort of take that feedback on where you say, can you sort your model out and get this info in there?
Yeah.
Do you end up sort of doing it yourself?
Again, it's like a mixture of things, really. We get some architects who are nice and collaborative, and sometimes, like you say, it's just we just end up taking the model and just putting all the thermal data in ourselves. So this is a feature that we're really only just starting to use on projects. So actually, to come back to your question before, this heating load stuff is something we're really only trialing at the moment. But yeah. And so is it okay if we just have one more question? We're not going to be thrown out the room, yeah. And you probably want a coffee or something, but we'll take a question.
Cheers. I'm also from Arup, different office to Andy.
Yeah.
We've got a very similar workflow, but the problem comes where we've got an open plan office or something like that where you're using BCO sort of zoning.
Okay, yeah.
Have you, because I'd love it if you have you got a sort of workaround to get your spaces or your zones from IES into Revit, so you can do the same process, but not based on the architect's rooms, but based on your spaces?
Like subzones
Exactly.
within an open plan office.
Yeah.
So I'm probably teaching you to suck eggs, but off the top of my head, the best thing I can suggest, let's find an open plan office. The best thing I can suggest is just using space separators, right?
Yeah.
Which is what you've probably done. And rather than bringing it in from IES, like splitting it up in here first, and then, your zones would be like this or whatever, 4.5 by 6 meters. So then then you'd export your spaces to IES and bring them back in again. Which is another reason why the IES connection can be a bit frustrating. So like I say, quick answer off the top of my head, that's the best thing I can suggest, really. Yeah.
All right, thank you.
Yeah, all right, thanks. Yeah, thank you. Cheers. Sorry for keeping you. I'll hang around if anybody wants to chat. So, thank you very much.